Hello. Now let's prove that x, y, z equals to 1. That is the product of x, y, z equals to 1. If this expression equals to this expression equals to this expression. Now the first thing we need to do, okay, is to what? Is to express these expressions, okay, with a constant. Okay, well that is we are going to represent each of these expressions, okay, with a constant factor, a constant value, and that will be a letter from the alphabet. So we can say that, let k equals to root ln x over y minus z. Okay, k again equals to root ln y over z minus x, and k will be equals to root ln z over x minus y. All right, so now from here we can now express ln x in terms of k and also express ln y in terms of k, and here we can also express ln z in terms of what? K, the constant. So let's do that. So let's express ln x, ln y, and ln z, okay, in terms of k, that is the constant. And to do that, we can say that by squaring both sides, okay, by squaring both sides. So for the first one, we're going to have k squared equals to ln x over y minus z. So in this case, we're going to have ln x to be equals to k squared bracket y minus z, and this becomes equation 1, okay? That means we express ln x in terms of what? The constant. All right, then also for this one, it will be k squared equals to ln y over z minus x. So which means ln y will be equals to k squared bracket z minus x, and this becomes equation 2. All right, then also for the last one there, we have k squared to be equals to ln z over x minus y, and that will be ln z will be equals to k squared bracket x minus y, and this becomes equation 3. All right, so now we've been able to express ln x, ln y, ln z in terms of k. So the next thing to do is to what? To add the three equations. All right, so let's add the three equations. So that means when we add ln x, ln y, ln z, that will be on the left hand side. So we have ln x plus ln y, okay, plus ln z equals to, then we also add k squared y minus z, k squared z minus x, k squared x minus y, and that will be on the right hand side. So we have k squared, okay, bracket y minus z plus k squared bracket z minus x, then plus k squared, okay, bracket x minus y. All right, so now we have ln x plus ln y plus ln z. Okay, we can apply one of the properties of logarithms in this case. That is the sum of the logarithms of separate quantities. That will be equals to the logarithms of the product of the separate quantities. So that means we can write this as a what? As ln product of x, y, z. That is applying the property of logarithms. Applying the properties of logarithms, okay? We know that when we have ln x plus ln y plus ln z, okay, this will be equals to ln product of x, y, z. Okay, so which means the left hand side will be ln x, y, z, okay, ln x, y, z, that is ln product of x, y, z equals to, okay, so the right hand side, so we can now what? Remove the what? The bracket. So to remove that means when we remove the bracket, then we can then combine like terms after we remove the bracket. So k squared times y, this will be k squared y, then k squared times z, that will be k squared z, then plus k squared times z again, that will be k squared z. Then k squared times minus x, that will be k squared x. That will be k squared x. Then here we have k squared times x, that will be plus k squared x. K squared times minus y, that will be k squared y. All right, so that's it. Now, we can see from here that k squared minus y, k squared y, and minus k squared y, that will be equals to 0. Okay, then negative k squared z plus k squared z, that will also be equals to what? 0. Minus k squared x plus k squared x, that will be what? That's also equals to 0. So we'll be left with ln x, y, z, okay, on the left hand side equals to 0. Okay, because k squared y minus k squared y, that's 0. Minus k squared z plus k squared z, that will be 0. Minus k squared x plus k squared x, that will be 0. All right. Now, in this case, we know that when we say ln x, y, z, this is the same thing as when we have logarithm of the product of x, y, z to base e. Okay, so that means when we have log to base e, that is what? ln. Okay, so we have ln x, y, z equals to 0. So we can exponentiate both sides with base e. Okay, that is exponentiate both sides with base e, and that will be e exponent ln x, y, z. That will be equals to e exponent 0. Now, we can also apply one of the properties of logarithms in this case. That is when we have a exponent log b to base a, okay, that will be equals to b. So we apply that here because ln is what? Log base e, okay? So that means that we have e log base e of x, y, z. That is equals to e exponent 0. So that means the base are the same. And then we write x, y, z, that is the product of x, y, z equals to, now, 0 exponent. We know that when a base have a power of what? 0, then it will be what? 1. So that means that the product of x, y, z is equals to what? 1. And we just proved that product of x, y, z is equals to 1. The noblest pleasure is the joy of understanding. Bye-bye.